my operand equals my waiting operand plus my operand. Okay, notice there, I've taken that string literal, @plus, I sent it a message. And it's in a string just as much as waiting operation is. I could have put it the other way around. I could have sent waiting operation the message, right? Asked it if it is equal to quote plus. But I can also send a message to @plus saying, are you equal to waiting operation? Okay, I just want you to make sure you understand that strings are real objects. Okay, they're created for you, but they're real. All right, so let's do our other operations here. Minus is equal to waiting operation. I might do some copy and paste here if you don't mind. So that would be operand equals waiting operand minus operand. You've got to be a little careful of the order here, but I believe this is the right order. We'll do some copy and paste here for the last two. Copy, paste, paste, paste. Let's do times is times. Some of you are saying, ooh, divide. What's going to happen with divide? Because if I go like this, what happens if operand is 0? That's going to crash. Okay, that's divide by 0, not allowed. So I'm just going to silently fail. If we were writing a real calculator, we'd want to put up an error message or something. But I'm just going to say, if operand, then do this. Otherwise, just do nothing. Okay, so that's not very good coding, but I only have so much time today. All right, so this is the implementation of our calculator brain. Pretty straightforward. Okay, we can build and run at this point, make sure we have many errors. Look, there's all kinds of errors here. Why is this? Well, because I forgot parentheses there, so let's fix that. You can see these red errors will tell you in line, like expected parentheses before square bracket, which is really convenient. You don't have to go to that build results window if you don't want. So we'll try that. We'll build there. I still have another one here, which is, what did I do wrong here? Expected semicolon before open square bracket. Oh, else if. How about that? If. So you can see that it takes somewhat of skill to interpret compiler warnings. Okay, so now I've built, and it's succeeded. Build and run. By the way, I was hitting there build, which is not build and run, but just build. I'll show you where that is in a second. Again, if I press a button here, crash, because I still haven't implemented my controller. I've only implemented my brain. Okay, and the controller's not using the brain yet to do anything. Here's where I did the build. It's right here, Command B. That just builds your program. Build and analyze is kind of fun to play with. It actually builds your program and tries to look at the code to make sure code paths make sense. So that's kind of a fun one to play with. But anyway, so there's our model implemented. The last thing we need to do is to build, to do the implementation of our controller. So that's pretty straightforward as well. So let's go to controller right here. Here's our, we don't need to change our API. It's everything we need. I'm actually going to copy and paste these two method declarations into my implementation, just like I did with my brain. You notice all this commented out stuff and that's in here in the controller. You don't need any of that for this assignment. In future assignments, some of that stuff you're going to uncomment and actually use. But here we're just going to select it all, delete it, and I'm going to paste in those methods. I'm going to put my curly braces in here, just like that. Okay? Oops. Save all. All right. So how about the implementation of this? What's required here? Let's start doing the operation. Okay, we're going to start with the implementation of that one. The first thing we need to understand from the operation is which operation are we doing, right? So we got sent this message from a button. We're in our controller. The view sent us this message using target action. We're the target. It sent this action to us. Which, operation got pressed? Well, the way we're going to find that out is we are going to send a message. I'm going to have a local variable here, which is a pointer to an operation. And I'm going to send a message to an object that is returned by sending another message to find out. Now, what's happening here with this nested message sending? Okay, this message right here, sender title label, sends the message title label to the sender, which is a button, right? Sender is UI button right here. Title buttons, when they draw their text, they actually use a UI label to draw their text, which is kind of nice object-oriented reuse, I think. And so if we want to get the title of a button, we ask it for its label, its UI label, and then we're going to send a message to that UI label saying, what's the text on you? And that's what this message is. Now, this kind of nesting of message send inside message send, super common. In fact, you want to code that way. It's not like, oh, this is making unreadable code. And in fact, if you read this from left to right, it says a string, which is operation, is equal to sending the sender title label and asking it for its text. So you can kind of fill in some prepositions and words and read this left to right, and it'll read just fine. You could, of course, separate this into two different lines of code and all that, but this is generally the way you would code this. Now, the next thing we need to do, we have our operation. We need to tell our brain to perform that operation. All right? But where is our brain? We have this instance variable for it right here, but we don't ever actually create it. It doesn't actually exist. All the stuff in our view got created by Interface Builder, but our brain doesn't exist. So we need a method, and I'm going to add a method at the top of my implementation here that returns our calculator brain, just for convenience. I'm going to call the method brain. Same thing as my instance variable, which is perfectly fine. I'm going to say if my instance variable brain is not set yet, and it's perfectly fine to check object pointers implicitly with the exclamation point saying not. Okay? If it doesn't exist, then I'm going to create it. And this is how you create it. Don't worry about this syntax. We'll talk about this later. And then I'm just going to return my instance variable. So this is a method lazily instantiates our model from our controller. This kind of lazy instantiation is pretty good programming style, especially on an embedded device. An iPhone, the memory is not unlimited there. You definitely want to not create memory until you have to. So this kind of lazy instantiation, really valuable. Now, how do I use this in a line of code? How about this? Double result equals self brain perform operation. Okay? So here, I'm using the nesting again. I'm sending self brain to myself. It returns my own instance variable called brain and creates it if necessary. And then I send it perform operation with the operation which I got from the title label's text from my sender. Make sense? What's going on here? Good. So now I've got the result. I need, by performing the operation, now I need to update my display. Conveniently, I have that outlet that I created called display. And so I just say display, set your text. It's a UI label, so it responds to the method set text. And I'm going to create a string version of that double using a kind of a utility method message that I can send to the string class, which is string with format. %G, same kind of format that you'd see in printf, basically. Just like that, okay? So everyone got these three lines of code? I'm basically just getting the operation, performing the operation in my brain, because it's the thing that's a model, it's the thing that does the work, and then I'm setting the result in my display. All right? Now, there's one kind of weird thing here, though. If I type 345 times, when does that 345 become the operand of my calculator brain? Never. I need to call set operand somehow. Okay? So when do I call set operand? Well, certainly every time the operation is pressed, I want to take whatever number's in the display and make that be the operand. Okay? But there's kind of two states. If I say 3 times 5 plus 4, then there is no number being entered. Okay? It's the previous result. So I kind of need to know in my controller whether I'm in the middle of typing a number. All right? So I'm going to have an instance variable called if user is in the middle of typing a number. Now, you might laugh, like, whoa, what kind of instance variable name is that? But actually, it's a good instance variable name because we're trying to write code that reads like English. So if I say if the user is in the middle of typing a number, then I'm going to say self brain set your operand to be the display's text converted to a double. Okay? And of course, if that happens, then I'm no longer in the middle of typing a number. I just set the operand, so user is in the middle of typing equals no. Now, I also need to add this as an instance variable, so I'm going to go back to my header file, and I'm going to make this a bool. So There is no Boolean when ANSI C. When Objective-C was created, there was no Boolean type. So Objective-C called it bool. User is in the middle of typing a number. It's too bad it's not helping me more there. But it did notice that that is used somewhere else. So that's simple. You kind of could ask the other question, which is, we're setting it to no here. Where does it ever get set to yes? Well, it gets set to yes anytime you start typing digits. Because as soon as you start typing digits, now the user's in the middle of typing a number, right? So up here in digit pressed, we want to have if the user is in the middle of typing a number, then the display wants to be updated by setting its text to the current text in the display plus a string by appending string the digit the person typed, which we have to get from the sender, which we'll do in a second. More square brackets. Otherwise, if we're not in the, so if we're not in the middle of typing a number and someone types a digit, then the display just wants to be set to that digit, and now user is in the middle of typing equals yes. Okay, bools types are yes or no. Now, the only thing we have left to do is this digit thing. Okay, I've used this variable digit twice here, but I have to set it. It turns out to be very easy to set. NS string start digit equals sender title label text. Okay, when digit press gets sent to us, the button that's sending it, its title labels text is the number. Make sense? So all we're doing here, getting that title number and just appending it on to what you've typed so far, unless you're not in the middle of typing something, in which case we start. Everyone cool with that? If you're not really getting that logic, you can stare at that code offline. It's pretty straightforward. So we're done. I believe that's it, and our program should work entirely. So let's build and run. Oops, we have errors. Let's see what our errors are. Okay, we need a square bracket. There we go. And build and run. All right, so this is where you cross your fingers, pray for the poor instructor. Let's try 5 times 9 equals. Oh, look at that, it works. Divided by 6, 7.5. So our calculator even does floating point. And plus 3 equals, or we can start over, 2 plus 6 equals square root. Okay, so real simple. Hopefully not a lot of code to pour through to understand how that works. And hopefully you understand where the view is, where the controller is, where the model is. All right. Now let me talk briefly about your homework. So your homework is, first of all, to build this. Okay, and that's mostly so you get experience with Xcode and Interface Builder and wiring things up, writing the code, getting used to the syntax of sending messages a little bit. So that's part A. And then part B is that you're going to extend this. Now, one of the ways you're going to extend this is you're going to allow entry of floating point numbers. So 5.7 times 3 equals. Okay. You're also going to add a few more operations and a couple other things, but that's generally what you're going to be asked to do. The homework and the walkthrough, I told you there's a completely detailed walkthrough of everything I did today. That's all posted on the website, and the homework is due. It's assigned now. It's should be up there now, and it's due next Wednesday by the end of the day, meaning 11:59 p.m. for those who are exacting about those things. If you have any questions, feel free to ask me or any of the instructors by email or whatever. And next week, we will go into great depth about Objective-C, and we'll be in the homework extending our calculator to do even more cool stuff. So that's it for today. Thank you.
For more, please visit us at stanford.edu.